Good evening to everyone. Today we are going to see about the topic is a routing information protocol. So this protocol is mostly widely used in a real time and it is used as an intra-domain routing protocol algorithm. It's working based on the distance vector routing algorithm. So this is developed by Xerox Network Systems at a Berkeley software distribution version of Unix. So this is the graph example graph given in a Farazan book Data Communication and Networking 5e. So this is the example graph as I taken from this session. So it have four routers and then six nodes. So first, before going to calculate that, we must know what is the distance vector. So distance vector means it is a one-dimensional array to maintain the distance of shortest distance of nearest neighbors. So based on this vector, we are applied into Bellman-Ford algorithm formula. So in that, by using this combination, we got a new routing table. So in the table we have shortest path of nearest nodes. So the same way in this graph also, we have calculated first the initial routing table of each router. So in that routing table, it have three columns. So in that three columns, first one is a destination, next one is a next hub, third one is a cost or distance, etc. So first I want to calculate the routing table for R1. So first what are the nodes are joined in the router 1. So I just specify N1, N2, N3. There is a no next hub because router is the nearest to next join to router 1. So I taken as a hub count 1. So now you want to know what is the meaning of hub count. So I am just giving a value as 1, how it is obtained. So when we have the direct link between router and node 1, the cost of between those two systems are be taken as a 1. So in case I want to transfer a data R1 to N4, in that we must transfer our data through R2 router. So that time the hub count is automatically increased to 1. So we take given as a 2. So the same way, in case I want to transmit a data to some devices through one or more routers, so the number of routers plus 1 is the hub count. So this way only we can calculate the hub count in a routing table. So the first one is a N1, N2, N3. In that we don't have any next hub. We are assigned a hub count is a 1. So next the routing table R2. In that R2 we have 3 nodes N3, N4 and then N5. In that we don't have any next hub. I am just putting nothing. So hub count is a 1. The same way routing table 3. So again we are creating a new routing table for 3. First one is a destination, next hub, cost. So what is the links in the router 3? We have N4 and N6, the same way. So the same way router 4 also we can compute. First one is the destination, next hub, cost. So in that router 4 we have only two links, that is N5 and N6, each have one hub count. So this is the basic routing initial state of the routing table for each router. So by using this routing table, we calculate the new routing table. This is the final routing table. This one is the initial routing table. So this is the final routing table, how we can calculate. So the same way we also creating destination. The same routing table will come for the final table also. The same attribute we are used in the final thing also. But we want to transfer our data to all the nodes in the graph. So any nodes we are taken as a source node, any nodes we are taken as a destination node. The same way, now we are going to find the router 1. So based on the router 1, how we can optimize the distance between these nodes. So this is our solution. So next, N1 have 1, so it does not have any next hub. We can directly give the routing table 1. So the next N1, N2, from N1 to N2 we have 2 links. So sorry, router 1. So this is the routing table for router 1, the same thing. So next again we have directly connection to the N3, node 3. So we can just give the same way. So now we can calculate the routing shortest path to routing table R1 to N4. So already we have one hub count. In case we cross the one router, then hub count is automatically 2. The nearest hub is R2. The same way N5, the same way we can cross R2 after only we reach the node 5. The same way it is also the same answer. N6, from R1 we can reach the N6 through 2 routers, R2, either R2 or R3 or R2, R4. So now we cross the 2 routers, so automatically the hub count will be 3. Then next hub means the nearest router of R1 is the R2 only. So same way we can calculate for all the routers. All the router means we are used 4 routers only. All the routers. So the same way N1, N2, N3, N4, node 5, node 6. So next we have an initial table. So in that N3, N4, N5 we have already in a shortest path, minimum shortest path. This is the one already one hub count only. So we no need to again no need to find out again one more time. So next N1. In case from R2 I want to reach a N1. So I want to cross the one router, so it automatically R1, 2. The N2 same way, it's only near of the opposite of the N1, the same thing will happen. So N6 we can cross either R4 or R3, but we must prefer in a alphabetical order. So we cross a R3, the hub count will be 2. The same way routing is a routing table 3. Destination, next hub, cast. So N1. So in that, so R3 have N4, N6. So N4, N6 we just using the initial table. So when we are reaching R1 to R3 to N1, we want to cross the next 2 routers. So hub count is a 3. The same way R2, 3. In case N3, we are crossing only one router. So we directly just put a 2 R2. So for N6 we have direct link, so we can okay, fine. So next now we want to find the routing table for the routing table of fourth router. The routing table of n5, n6, so we directly put that. So and then from our router 4, we want to come to routing. Sorry. So we want to, from the router 4, we want to come the n1. So we are crossing two routing table. So next hub is a R2, 3. The same way R2, 3. N3 we are only crossing the only one router, so we taken as a R2, 2. N4 we are also crossing a one router, either R2 or R3, so I am just an R2. So this is a final routing table of each router. So in this way only we can calculate the routing table. So thank you.